And we are back. Welcome, welcome, welcome. Bismillah ar-Rahman ar-Rahim. In the name of Allah, the Beneficent, the Merciful. I bear witnesses, but one God whose proper name is Allah, who came to us in a divine person, but Master W. Fuad Muhammad, the great Mufti to praise to do forever. From the bear witness, the most honorable Elijah Muhammad, the living and soul to Christ, and the honorable Mrs. Fark, and your servant, honor, and Messiah today. I greet you all, the mighty, mighty SSOE High School Geometry class with the greeting words of peace and paradise we say in the Arabic language. Assalamu alaikum and happy Savior's Day. I pray all is well. I pray we are all feeling well. I pray we are all ready for the day and that we are excited for our Savior's Day convention. Inshallah, we've seen many of you, some for the first time in person, some for several times at this point in person in Detroit. All right, so at this time, we've gone through three geometric transformations, specifically rigid transformations and reflections, and then translations, and most recently, rotations. As we know, a reflection is simply a turning of the page from one shape to the other, right? In that situation, the shape and the size does not change, but the orientation does. It's literally a mirror image where each original point is met directly onto the reflected shape of the other one, and all the corresponding points are um, equidistant from the point of reflection or the line of reflection from the other. Also, we know for translations, we know that the size and shape stays the same as well as the orientation. All you're doing is shifting the shape left, right, up, down, or in some way diagonally from its original position. And lastly, a rotation has both um, a center of rotation and an angle of rotation. The center of rotation is the point around which the shape is going to rotate, and then the angle of rotation is how much that shape will rotate around that center, right? And then there's specific rules associated with how to now change, one point to the new point with a certain amount of degrees rotated. All right. Today we're going to talk about compositions or composite um, transformations that actually house or contain one or more, well, two or more of the previous topics learned, or previous transformations learned. So let's go ahead and get started. All right. So we're in chapter 23, compositions, compositions. When you think about that word compositions, it's like composite, meaning more than one. In material science, is a certain type of material class called composite materials, which basically is two or more of the basic types of materials, metals, um, ceramics, polymers, etc., combined for greater material properties. So compositions is going to be two or more of the transformations combined for a new transformation that is more robust and more comprehensive. So compositions of transformations. Compositions of transformations combine two or more transformations to form a new transformation. Exactly what we were just talking about. So all it is taking the rules you learn for reflections, translations, and rotations and combining them depending on what the composite transformation asks you to do. So you're going to basically do the rules for each transformation one at a time and then do it one after the other. So if it says translation and a rotation, you're going to translate first. And then once you get to the new image or the image after the translation, then you're going to take that translation and then rotate that the way they ask you to do so. All right. So it says in a composition, you perform each transformation on the image from the previous transformation. Very key. So this is very key right here. And this is how you're going to keep your mind straight as far as like what step you're on. So like I said, I don't like that. So in a composition, you perform each transformation on the image from the previous transformation. So let's say, for example, right, it says, so you would do like, for example, if it says, hey, do a reflection and then a translation, okay? So you're going to take like the shape here, right? You're going to do the reflection first, right? Let's say if it has you reflect in a certain way, right? Let's say this is the actual reflection, how it's supposed to be. That's the reflection first, so you're gonna reflect first. Then let's say, oh, then it says translation. Then let's say it has you translate down here. That's the order you're gonna do it in, and this will be the final image here, right? So all this is saying is the order in which it asks you to do transformations is the order that you're actually going to do it. And every time you finish or complete a transformation, that new shape, or for example, that image becomes the pre-image for the next translation. So you start off with the original image, which is the pre-image. Then you do the first transformation that gives you an image. Now that image becomes the new pre-image. You do the next transformation from that first transformation. Does that make sense? So as we move forward, we're going to go ahead and they're going to show us more. So it's just building blocks. It's like when you play with Legos, right? You start with the foundation, then you stack one on top of it, then you stack one on top of that, right? You can't stack the third block on the first block because the second block is in between. So you do each step after you do the previous one. So example of a composition of transformation. The green fish is reflected to the pink fish and then translated to the yellow fish. So you see that? You flip the page for the reflection, green to pink. Then, so now in this case, right, the green fish is the first pre-image. I know it's not hyphenated, but I want to do it. So now, and then the pink fish is the first image, right? So that's for the first transformation reflection. But now to go from the image to this image to this translation, this becomes a pre-image as well. And that becomes the final image. So again, all it is just combining. It's really simple. It's really, really, really simple. It's taking everything you learned before, and instead of just doing one transformation, you're doing two or more. Instead of doing one transformation, you're doing two or more, and you're utilizing the same rules. You're just combining them. The same rules are being combined. All right, so example, draw the graph of line segment JK rotated 90 degrees counterclockwise about the origin and then reflected across line Y equals 1. Okay? So now rotated clockwise about the origin. So you're going to take JK, first you're going to rotate it 90 degrees counterclockwise. That'll be step one. Graph of JK rotated counterclockwise about the origin. That's one. Then step two, reflected across line Y equals 1. This is step two. So you're going to do the rotation first, then in that new image, you're going to reflect that new image across line Y equals 1. So let's go through the remaining steps and see how they did it, okay? So it's a step one, rotate line segment JK 90 degrees counterclockwise about the origin. So remember, use the rule. x comma y maps to negative y comma x. We learned in the last chapter 22 for rotations that that is the rule when rotating 90 degrees. So now we find out that, okay, where's J? J is 3 comma 6. Right? K is 7 comma 2. 3 comma 6 is going to become what based on the rule? Well, xy becomes negative y comma x. So negative y in the x is going to be negative 6. So it goes to negative 6 and then 3 of 3. That's the new J prime. And then 7 comma 2 becomes, so the negative, you put a negative y in for x, negative 2 comma 7. So negative 2 comma 7. Right here, that's going to be k prime, negative 2 comma 7. Then you're going to connect those dots, and that's your rotation of 90 degrees using the same rule that we learned in chapter 22 for rotating a figure 90 degrees clockwise or counterclockwise. So let's go ahead and keep moving. Right? So J 3 comma 6 maps to J prime negative 6 comma 3. K 7 comma 2 maps to K prime negative 2 comma 7. And we have the new one. So let's now connect the endpoints. Label the points with double prime when an image is reflected the second time. So you go from, so when you do the first, the first transformation, for example, let's say you go from triangle ABC to now the new triangle, all right? However however the transformation is, the new triangle is going to be labeled triangle A prime, B prime, C prime, right? Because remember the primes are used for when you do the transformation. But then if you do another transformation, it's going to be triangle A double prime, B double prime, C double prime, right? You add a prime every time you do a transformation. And if you were to go again, then it would be A triple prime, B triple prime, C triple prime, and so forth. However many times you transform, it's however many primes you're going to add, right? So let's go to step 2. Reflect J prime, K prime, line segment J prime, K prime across line Y equals 1. So here we go. You got a graph. So here we go. Y equals 1 is right here, right? So you go up to 1 from the origin, and then you draw a line horizontal. That's Y equals 1. J prime is 2 units above Y equals 1. So place J double prime 2 units below Y equals 1, right? So you got to, again, mirror it, right? You just mirror, you reflect the mirror. So from here is 2 above here. So you want to reflect it 2 below. K prime is 6 units above Y equals 1. So place K double prime 6 units below Y equals 2. So we go 1, 2, 3, 4, 5, 6. So then the reflection is going to be 1, 2, 3, 4, 5, 6. And that's it. So now that's the new transformation. J double prime, K double prime is down here. And notice again, you did not do this transformation based off the original pre-image. You did it based off of this intermediary image. That's going to be what you use to do the final transformation. So you went from line segment JK to line segment J prime K prime using a rotation of 90 degrees counterclockwise, and then you went from line segment J prime K prime to line segment J double prime K double prime using a reflection over the line Y equals 1, and you connect the endpoints. And that is an example of a composite transformation using 2 rigid transformations. Very simple. All you're doing is stacking the skills that you learned in the previous chapters, one after the other. Each time you do it, you focus on one skill and you do what that skill is supposed to be done by itself. Then you go to the next one and build off of the transformation you just did with the new skills. Composition of translations. A composition of translations combines two or more translations. This is really simple. This is really simple. It's like if you play chess, anybody, or checkers or chess in particular, you like, you move laterally, you might move diagonally, but it's like saying, okay, I'm gonna go 5 units to the left and then 7 units down. That's a composite translation, right? I'm not a chess player, so I don't know exactly how all the pieces move, but I do know there's some pieces that can go like vertical and horizontal. So again, a composite translation is like, oh, let me go 7 units up and let me go 5 units to the right. Done. I have translated in a composite manner. Okay. So now an example of this type of composition. The yellow dog is translated to the pink dog, and the pink dog is translated to the blue dog. Literally, X amount of units to the right, X amount of units down and to the left. That's a composite translation, right? A lot of times, the simplest ones are going to be when you do more than one of the same type of translation because it's going to be the same rule twice. Just in a just you're just doing it in accordance with how much you're moving or how much you're rotating or how much you're reflecting. So in this image, triangle A is translated to triangle B. Triangle B is translated to triangle C. So triangle A is translated to triangle C in the end. Composition of two translations is another translation. So in the end, the original triangle A was translated to triangle C. But the pathway is a composite translation of A to B and B to C, with the resultant being A to C. Okay, really simple to understand. The original point, the original placement is triangle A. The final placement is triangle C. So again, triangle A ultimately got translated all the way to triangle C, with going, but it broke up the path in two steps, going to B and then going from B to C. All right, so now we want to go ahead and do our next example. It says describe the transformation from segment DE to segment D double prime E double prime. Okay, so you want to describe this. So if we look at this, you got DE, then you go D prime E prime, then you go D prime, D double prime, E double prime. So there's a way to describe this. So let's see what they did. D segment DE is translated along vector -4, comma, -1 to D prime E prime. Right? So let's see how he did that. How do you get vector -4, -1? So from D to D prime, you're going to go over 1, 2, 3, 4, -4, and down -1. From E to E prime, you're going to go 1, 2, 3, 4, -4 spaces, and go down -1 space. So the vector transformation so that's how you get -4, -1 for the vector translation from segment DE to segment D prime E prime. All right. And now let's see how you get it from D prime E prime to D double prime E double prime. D prime E prime is translated along the vector 4, comma 3 to segment D double prime E double prime. So let's see how they get that. So from here to here, so from D prime to D double prime, you go to the right how many times you go to the right? You go to the right 1, 2, 3, 4, and up 1, 2, 3. 4, comma 3. And from E prime to E double prime, 1, 2, 3, 4, 1, 2, 3, 4, comma 3 again. And that's how you describe it. So you say translate it along a vector, and then you do however much you go over left or right, and however much you go up or down. And that's going to be your X and Y coordinates for the vector. So you're translating along some vector from one to the other, and you're translating along another vector from one to the next. Let me see. All right, so this is a composition of two translations, a composition of two translations, right? So the result is also a translation. To find the translation vector, we can either count the units from D to D double prime or E to E double prime. D moves 0 units to 0. It's asking for the translation vector from D to D double prime. So D moves 0 units left or right and 2 units up to map to D double prime 0, comma 2. Or add the coordinates of translation vectors -4, comma -1, and 4, comma 3. So -4 plus 4, because of the x coordinates, is 0. -1 plus 3 is 2, so 0, comma 2. So the transformation from segment DE to segment D double prime, E double prime is a translation along vector 0, comma 2. Right? Now, that's going from here to here. The final translation is 0, comma 2. So you did the translations for each individual from here to here and here to here, and then you add those up in order to get the final translation vector or the complete translation vector from the first segment to the final segment to be 0, comma 2. And all that is combining or adding up the x coordinates and y coordinates, or doing the same thing you did originally by counting the spaces left or right, up or down to get the final translation. All right, last we have glide reflections. A glide reflection is a translation followed by a reflection. A glide reflection is a translation followed by a reflection. Okay, so all it is a fancy way of saying, oh, a composition of a translation and a reflection. So you're moving left, right, up or down, and then you're reflecting once you get to that point. That's all it is, right? So that's just a fancy way to say it, glide reflection. It's a translation followed by a reflection. Reflection line is parallel to the direction of the translation. Very key as well. The reflection line is parallel to the direction of the translation. So whatever way you're translating, that's going to be the line over which, or the direction over which you're going to reflect. So the example of a glide reflection is the gray cat translates to the purple cat and reflects to the green cat. So again, it moves to the right from gray to purple. Then because the direction was to the right, that's going to be also the direction of that's going to be the direction of the reflection line. So the reflection line is also going to be left to right because the translation was left to right. Then you will flip top down or top to bottom over that reflection line. So as we get ready to land the plane, I think this is roughly exactly where I wanted to be. Let me go back up. This is the first 5 or so pages. All right, so it says draw the glide reflection where triangle ABC is translated along vector -4, 0, and then reflected across the x-axis. All right, so this is giving us very specific things, right? So we're going to draw the glide reflection where triangle ABC is translated along vector -4, 0, and then reflected across the x-axis. So all this is again a combination of a translation and a reflection. So the -4 is the x coordinate, the 0 is the y coordinate. So we're going to take each one of these points and translate it by this vector, and then reflect over the x-axis. So let's break it up. So we'll say A, since it's -4, we're going to go to the left 4. 1, 2, 3, 4. This is going to be A prime. Now, Y is 0, so we're not going to move anywhere in the Y. So we're just going to be that movement right there. Same thing with B. 1, 2, 3, 4. B is here. So now it's B prime. Same thing with C. 1, 1, 2, 3, 4. C is going to be here for C prime. And that is going to be, I know what now, that's the first image. Now we got to reflect it across the x-axis, right? So now to go to the double primes, A double prime is 2 units away from the x-axis, so it gets 2 units above. B is 1 unit below, 1 unit above. C is 1, 2, 3 units below, so go to 3 units above. Now you got A double prime, B double prime, C. And that's it. Let's see if that's what they got. Translate vector, translate along vector -4, 0. So A1, -2 maps to A prime -3, -2. B2, -1 maps to B prime -2, -1. C4, -3 maps to C prime 0, -3. Exactly what we came up with. Plot the points against the vertices. And then lastly, reflect triangle A prime, B prime, C prime across the x-axis. A prime -3, -2 maps to A double prime -3, 2. B prime -2, -1 maps to B double prime -2, 1. C prime 0, -3 maps to C double prime 0, 3. And that's exactly what we got. We plot the points and connected the vertices. So last thing we want to do before we end is the key properties of rigid motions. So the rigid motions we have are reflection, translation, rotation, and glide reflection. So size stays the same. Reflection, yes. Translation, yes. Rotation, yes. Glide reflection, yes. Remember, they are rigid motions. So a rigid motion is not going to change the size. Angle measure stays the same. Reflection, yes. Translation, yes. Rotation, yes. Glide reflection, yes. Orientation stays the same. Reflection, no, right? Because you're reflecting over, so it's literally like flipped. Translation, yes. Rotation, no. Glide reflection, no, because again, it starts off with a translation, then it goes to reflection. And if a reflection has a different orientation, so too does a glide reflection. All right. That's a good thing for your notes. All right. So with that, we have ended today's subject. I pray we gathered enough information and understood. Again, all this is building off of the previous chapters where we talked about the singular rigid transformations. We just combine them for composition so that you can see how you can combine different ones to get a completely unique and new transformation from 2 or more previous transformations. All right. If you learn how to stack those skills, you'll definitely do fine. So I'm gonna go ahead and leave you as I came before you with the reading words of peace and paradise. We say in the Arabic language, Assalamu alaikum, and also happy Saviors, everyone.